In this video, we're going to continue our discussion of work integrals. So here we have the work required to stretch a spring from 10 centimeters to 12 centimeters is 6 joules. It takes an additional 10 joules of work to stretch the spring from 12 centimeters to 14 centimeters. What is the natural length of the spring? So we start with the work formula. Work is equal to integral from a to b, f of x dx. According to Hooke's law, f of x is just kx. So integral from a to b, kx dx. So we're given that 6 joules of work are required to stretch a spring from 10 centimeters to 12 centimeters. So 6 is equal to integral from, now it would be wrong to say that the integral simply goes from 10 centimeters to 12 centimeters because we have to subtract the natural length of the spring. X is the stretch beyond equilibrium. So we have to subtract L. This is the correct thing to do. Subtract L. Kx dx. And 10 joules of work are required to stretch the spring from 12 centimeters to 14 centimeters. But bear in mind that X is a stretch beyond the natural length, beyond equilibrium. So you have to subtract L from 12 centimeters and subtract L from 14 centimeters. 0.12. Very easy to make a mistake here. 0.14 minus L, integrate kx dx. So we have a system of equations, and our goal is to solve for the natural length of this spring. So repeating this key concept, we have to subtract the natural length of the spring from the position of the spring. The reason for this, of course, is that x represents the stretch of spring beyond equilibrium. So x is equal to, we have to subtract the length, 0.10 minus L. X is equal to 12 centimeters, 0.12 minus L. X is equal to 14 centimeters, 0.14 meters minus L. So we have 6 is equal to integral 0.10 minus L. Lower limit of integration. The upper limit of integration is 0.12 minus L. Kx dx. 6 is equal to integrating kx, we get kx squared over 2, reversing the power rule, and evaluate this from 0.10 minus L to 0.12 minus L. So 6 is equal to k over 2 times, putting the upper limit in, applying fundamental theorem of calculus, we get 0.12 minus L all squared minus 0.10 minus L all squared. Now looking at the second equation, we have 10 is equal to 10 joules of work are required to stretch the spring from 12 centimeters to 14 centimeters. So 10 is equal to integral from 0.12 minus L to 0.14 minus L kx dx. So we get 10 is equal to kx squared divided by 2 from 0.12 minus L to 0.14 minus L. So we get 10, applying fundamental theorem of calculus, 10 is equal to k over 2 times, put the upper limit in, we get 0.14 minus L all squared, minus, put the lower limit in, we get 0.12 minus L all squared. So we now have two equations that we have to solve, and our goal is to solve for the natural length of the spring. These are the two equations, and now we're going to solve for L. That's going to be a lot of algebra. All right, so we have 6 is equal to k over 2 times 0.12 minus L all squared minus 0.1 minus L all squared. And 10 is equal to k over 2 times 0.14 minus L all squared minus 0.12 minus L all squared. Our strategy will be to divide the two equations to solve for L. So when you divide these two equations, let's put a divisor here, 6 divided by 10, and the right-hand side gets divided, you get numerator over denominator. 6 over 10 simplifies to 3 over 5. K over 2, that's just constant, cancels out. So we get 3 over 5 is equal to, in the numerator, we get 0.12 minus L all squared minus 0.10 minus L all squared. In the denominator, we get 0.14 minus L all squared minus 0.12 minus L all squared. We're going to apply difference of squares to simplify this further. So we have a squared minus b squared is equal to a minus b times a plus b. We're going to apply this property to simplify this ratio. So we get 3 over 5 is equal to, for the numerator, we get 0.12 minus L minus 0.10 minus L times 0.12 minus L plus 0.10 minus L. So this part, this is all like a. So a squared minus b squared, and this part is b. Divided by, we do the same thing to the denominator. So apply difference of squares, factorize it out, we get 0.14 minus L minus 0.12 minus L times 0.14 minus L plus 0.12 minus L. So we get 3 over 5 is equal to 0.12 minus 0.10, that's just going to give us 0.02, minus L minus minus gives us a plus, minus L plus L, that's 0, so we just get 0.02, times, we get 0.12 plus 0.1, that's 0.22, and we get minus L minus 2L. In the denominator, we have 0.14 minus 0.12, we get 0.02 again. And we get minus L minus minus L minus L plus L, that's 0. So we get 0.02 times 0.14 plus 0.12, we get 0.26. And we get minus L, that's minus 2L. Now it's pretty simple to solve for L. So what we have is 3 over 5 is equal to 0.22 minus 2L divided by 0.26 minus 2L. We're going to cross multiply. We get 3 times 0.26 minus 2L is equal to 5 times 0.22 minus 2L. So we get 3 times 0.26 minus 6L, distributing the 3 across and distributing the 5. We get 5 times 0.22 minus 5 times 2, that's minus 10L. Now let's bring all the L's to one side, so we get minus 6L plus 10L. On the left-hand side, we're just going to get 4L. And on the right-hand side, we get 5 times 0.22 minus 3 times 0.26. If we simplify this, put it into the calculator, we're just going to get 0.32. So we have 4L is equal to 0.32. Divide by 4 both sides, so we can solve for L. We get L is equal to 0.32 divided by 4 is equal to 0.08 meters, or equivalently 8 centimeters. This is the natural length of the spring. All right, thanks.